The new video is about the strategies and scenarios to handle the main motor. Mostly how to run the drive, what are the startup phase, the stop phase, and the internal temperature of the drive. We monitor the internal temperature of the drive, and we limit the number of unsuccessful startups for a cold state, that we are in the cold state. The internal temperature of the drive, you can see the temperatures are 60. T1 is 60, T2 is 60, and T3 is 60. So the number of unsuccessful cold starts, 3 is the number. So when after 3 successful startups, the drive cannot be started, because we need a 1 hour cooldown, and the counter will be loaded again. So condition for a warm state of machine will be different. So this is the indication of a cold state of machine. If temperature 2 out of 3, if temperature 2 out of 3 of the temperatures are more than 75, the state of machine is changing to the warm state. So in case of a warm machine, when the machine is warm, the machine can tolerate only 2 hot starts during 1 hour. So we mostly want to block certain amount of unsuccessful startups in this example. That will be a very complex counting and using timers, and some startup and stop phases, application of timers in the startup and stop phases, and some binary applications to show what are the permission to start and this type of things, some indication. And statistics. In the statistics, we have a real-time RTM, real-time measurement for number of hours, minutes, and seconds, and the number of starts you can see here. And this is the timer, 1 hour timer that will refresh these two values. If they are getting 0, your machine cannot be started for 1 hour. Let us just start the machine in warm start, and monitor what will happen. So we press start, and after a pulse is sent to the MCC, the main drive, after delay, possibly 2 seconds or up to 4 seconds, the main drive will energize. The machine is running. We can see the speed is changing here during the startup. We didn't add all the complexity for this machine. The valves, we didn't cover those valves here, but you can see when the startup is finishing, the main valve to the header is opening, and the meaning is that the machine is in production. Let us move to the panel. Motor steady on. This is the signal to run the drive, and this is the feedback. There are some indications here. You can see that the number of hot starts decremented, and the number of total starts you can see here. And as the drive is running, you can see that the drive is green here. The RTM for seconds is counting, and in each 60 seconds we have 1 minute count up, and in each 60 minutes we have 1 hour. So that will give us a good understanding of number of hours that the drive is, or the whole machine is running, and that's a good measure for maintenance. So let us test the machine with a shutdown. So as an example, I can simulate a fault in drive, and you can see that we are in a stop phase. Main drive will shut down immediately. The speed is decreasing, and we didn't include the oil circuit. Normally, if the speed is non-zero, the drive is running. The speed is non-zero. The meaning is that the drive is running and the oil circuit is performing. What about the statistics? The number of seconds are it's frozen, so we need to wait until the next startup. This timer has a very plays a crucial role here. When we reach to zero, the meaning is that 1 hour time is elapsed, and these two values will reloaded with initial values. But we will start after the stop phase is finished, possibly 300 seconds. 300 seconds we have the stop phase. After this time is finished, we start the drive again. So because we are in a stop phase, it's not possible to start the machine again. So this time should pass, and you can see that speed is getting zero from 3000. It's getting zero, and that's the end of the rotation of the machine. Let me, during this period, let's just check see what's the program, how the program is structured. So we have all these program blocks are. It's a very simple program, and there are some simulation, some data blocks to, they store the constants and initial values, some blocks for simulation, some blocks for do the management, and these are we have a restart and OB35, cyclic interrupt, OB1 as the OB1 is the main routine of the program. Let us return. So we're getting so close to the end of the stop phase. Let's see the internal part of the program is developed in STL based on our course. That will be a very good example of STL programming for beginners, so they can practice STL programming in this course. So we wait until the stop phase is getting finished. So in this manner, we give the main drive great amount of time to cool down, to be lubricated all mechanical parts, and after stop phase is finished, we may have out of work, so this timer is finished. So we have a new mode of operation. I remove the fault on drive, and we have the permissive to start again. So when we start, we have the command on the relay, and after a while, 1 or 2 seconds later, we will receive the feedback from the electrical building, and motor is running. Forget about the start when this stop. So the important point is here is the number of hot starts are 0. So if we have a shutdown in this time, if you have a shutdown, or if you have a trouble during a startup, we need to wait 1 hour actually to be able to run the motor in hot start, or the temperature should be decreased to use the cold starts. So the motor is running now, and let me just simulate again. We have another fault here, and we have a fault, a stop phase, and anything here. It's similar to the previous stop phase, but the big difference is that the number of hot starts are getting 0. We cannot start the motor again because the restart is blocked here. So even after the stop phase, there shouldn't be the possibility of running the drive, and we need to wait 1 hour to be able to start the machine again. And that's the very important protection for this type of huge drives. So this timer should pass. It's 1 hour timer, and you can see gradually it's reaching to 0. And after this timer is passed, we will refill or reload these counters, cold starts, a number of cold starts, a number of hot starts. Now, because the temperature is more than 75, 2 out of 3, and you can see that this already indication here, we are in warm state, and there is no possibility to run the motor again during this period. So we should wait until the stop phase is finished, and after the stop phase is finished, we possibly have the indication here: block restart. Restart is blocked. This indication should be removed, and when this timer is getting passed or getting 0, that indication, that's a block, restart block, will be removed, and we will be able to run the motor again. So